Dear students, in this video I am going to discuss on important topic, that is equivalent force couple system. So in this topic let us consider that on this object there is one force acting at point A, that is this force. Now there is another point, say point B, on the rigid body. I want to transfer this force from point A to point B. So how to transfer that? That is the topic of discussion for under this heading, equivalent force couple system. That means if I want to transfer a force from a given point, so that is the given condition, and I want to transfer this from point A to point B, that is the desired condition or required condition, because point B may be a point of choice, that means maybe it's a center of mass or some point which may be convenient for analysis. So I want to transfer from this point to this point, because a force may be acting at a point which is in the situation, which is in a particular problem, but I want to, or I may need to transfer the force from this point to this point. That is a requirement. So if I want to satisfy that requirement, then what adjustment I need to do, that is the topic of discussion. Okay, so that means this is the given condition. I need to transfer the same force through this point, so that is the desired condition. So say for example I draw the same object. This is point A, this is point B. I need to transfer the force through point B. The same force I need to transfer, I need to see if it acts through B, what happens. Same force acting through this point, but we can easily see that they are not equivalent. That means if a force is acting at this point and the same force acting at this point, the effects will be different. But what adjustment I can do so that a force acting at this point may be transferred to act at a different point but effects are same, so that is to be done. Okay, so first we will draw this. So given condition, we start from the given condition. So how to do it? So we will see how to do it. Okay, so let us redraw this. Point A, point B. Initial condition given is this one. Initial condition given this one. This is point A. Now immediately what I can do is I can go for directly the desired condition. That is what is needed. I want to show it. So A, B, so this is the given condition and the required condition. Say I want to transfer. So I want to show that the force is acting here. Same force. Same force is acting at point B. So the force was, say, F. The given force was F. Okay. So this force is F. Same force F. And this force is also F. You see that they are parallel, they are having the same length. So all are F basically. And the perpendicular distance between them is, say, D. The perpendicular distance between them is, say, D. So this is the perpendicular distance between them. That means these two parallel lines are offset by a distance D. So next, what adjustment I need to do? That means you see that this situation, configuration A, say configuration A, configuration 1 and configuration 2 are not yet equivalent. Their effects are different. Here there is only one force, here there are two forces. So I need to go for some adjustment. So you see that if I nullify this force somehow, then this and these two configurations will be same. That means I have added one force here, this green force, along with this. Now if I nullify this force, then only this will remain and this will make it equivalent to this configuration. So that we will do. Therefore, to nullify this force, I will just add an opposite force here. That means this F force was along this direction parallel to this and along the same direction. Now I have added a different force in this direction. That means the opposite force in the that means in this direction at this point B. These two will nullify each other and this will remain, and therefore these two configurations will be equivalent. So therefore we can write that these two configurations are equivalent. So we can write equivalent. We see that we are mentioning the term equivalent, right? So they are basically same. Now this force is F, this is also F. Since we have shown in the opposite direction, negative direction, so I can just write the magnitude F, right? Now is this clear? So there are three forces. In the configuration 1 there was one force, and in configuration 2 there are three forces. These two are nullifying each other, therefore this remains same as this and therefore this configuration and this configuration, these two are equivalent, right? Now you see that our target is to keep this force only, not three forces. So that is the target that we want to achieve. That is the desired condition or desired configuration. So this is the desired configuration. Configuration or condition. Okay. Therefore, what I will do is I will keep this force and convert this to with a couple, because you see that these two are constituting a couple. Couple means a set of two forces equal, opposite and non-collinear. They are equal. F is same as F, opposite, this is in this direction, this is in the opposite direction, and non-collinear, so they will form a couple. Therefore what I will do is I will convert these two with a couple. That means I will make these two as a couple. That means this force will remain and these two will make a couple. Therefore I will do, you see that equivalent force couple system. So couple is coming, force is there, so one force is convertible to one force and a couple, one force, one force and a couple. So that is the meaning of equivalent force couple. Therefore what is the magnitude of the moment of the couple? Force multiplied by the perpendicular distance. So therefore if I draw the third figure, configuration 3, I redraw this object again. I draw 2 points A and B. B is here. Therefore I draw this force here. This is F. And these two will constitute a couple. What is that couple? We can write the magnitude of the couple. What is the magnitude of the couple? Magnitude of the moment of the couple. So that is M is equal to F into D, because these two forces having the magnitude F and their perpendicular distance is D. So moment means basically if I take moment about this point, then it will have a value of FD, or if I take a moment about this point, it will be having a moment of FD in the same direction definitely, or if you take moment about any point, then also it will produce FD, right? So that is the moment of the couple. So therefore in this case we have, what is the direction of the moment? From the top it is clockwise, therefore you can draw a clockwise moment here. So it will be a clockwise moment. So moment we can show like this, right? moment we can show like this. This is what? This is M moment. Therefore, configuration 3 configuration 3 is equivalent to configuration 2 is equivalent to configuration 1. So here there was one force. I have successfully transferred this force from this point to point B. Same force point B, but we have to adjust that force or that conversion with an equivalent or with a couple, right? And what is the meaning or what is the magnitude of the couple is connected, it is related with the force and the distance between the point, there is perpendicular distance between the point in along the parallel force direction. That means if we draw two parallel lines, then the distance between two parallel lines, that is d. Okay, so that is the conversion of force or transferring a force from a point to another point by adjusting with an equivalent couple. Okay, in the next video we will show the concept of range, which is related to this equivalent force couple system. Thank you.